Due to the COVID-19 lockdown that prevented us to meet, we decided to expose all our web services over the internet through ngrok. This tunneling service allowed us to reach any of the web services in the system despite they are running on a different localhost. The port in which each of the services is running is tunneled to a secure web domain accessible from anywhere. In this way, all the requests to the web services will be sent to the new URLs and the responses will be seen in the Python console as usual. Here is a map of the web service domain correspondence. Now we are using 3 computers. The first 2 computers are used to run all the web services, which are exposed over the internet through the ngrok clients. The third computer is used to run some clients, to run an MQTT to REST adapter, and will be used to launch the GUI client to perform the additions of the users. It is possible to consult the catalogs through a catalogs management client, which first performs a GET request to the service catalog to learn about the online services, and then allows the user to browse through the other catalogs. Interrogating the registered catalog, we can see now there are no registered users, while interrogating the sensor catalog, we can see there are no online streaming users. So, the presence of a streaming user over the platform will be monitored in the sensor catalog, while all the data related to all the users which have ever used the system are available through the registered catalog. This latter is also used to identify if a user is new. Opening the GUI, we will now perform the addition of a new user. A user can join the service through a GUI or using a Telegram bot. We will explain more about the second option later. Filling up the GUI fields, some personal details are needed together with the Spotify user ID. As we explained before, the user is new to the platform as is not in the registered catalog, which is now empty. Pressing the Start button will add the user to the system, and the stream of data from the heart rate sensor begins. As the user is new to the platform, the first time only, he will need to authorize the use of the Smart Music application in his Spotify account. Adding a new user, the GUI client will send a request to the authorization page web service that will perform the authorization process through the web browser, communicating with Spotify. The user will have to log in into his Spotify account and accept the conditions to use the API. Periodically, the application will ask Spotify the access and refresh tokens, which are unique for each user and essential to get the Spotify user data. Once this is done, the heart rate sensor starts streaming biometric data using a public MQTT broker. Here it is possible to see that the GUI client is publishing the sensor data. Using the catalogs management client, we can perform a GET request to the sensor catalog to see that the user sensor has started streaming. Through the sensor catalog, which is fed by an MQTT to REST adapter, the last 20 values of an online streaming sensor related to his user are available and always up to date. The MQTT to REST adapter behaves like a subscriber, and we can see it's receiving the data published by the GUI client. Performing a GET request to the registered catalog, it is possible to see that the user has been added, and that his data are now present in the catalog. We will now perform the addition of an already registered user who will be the second online. Using the Catalogs Management client, we can see from the registered catalog that the user we are adding is already registered to the application and all his data are available. Opening a new GUI, if a user is already registered to the application, after having checked his presence with a GET request to the registered catalog, The GUI client will not perform the authorization process. Moreover, if the user has already used the specific GUI client, he will have the possibility to only type his name and surname in the search bar, and pressing the search button, all his data will be automatically filtered in the other fields. Pressing the Start button, the sensor will start publishing. The MQTT to REST adapter receives the messages of both the users and feeds the sensor catalog. Using the Catalogs Management client, we can see that in the sensor catalog, as both the users are online, both their sensor data are available for any purpose.
Register to our system and start using it. I will talk about both Telegram and Spotify architecture. The first thing to do is to open the Smart Music bot and explore the lists of available commands. We can see that everything we write it is received from the bot's backend. If we try to write something that is not a command, then we will receive an error message. From this bot, we can also reach the authorization page, that is of course the same as before. In this way, one user can register to the system also from his smartphone. If we perform all the steps of authorization, we can see the data passing firstly from authorization page, and once we authorize the Spotify, from web service authorization. In the end, a new user will be added to the registered catalog. In order to understand what happens when a new user is added, we now talk about Spotify architecture. These two services, in red, get information about the user's preferences and process this data to extract important features, like favorite artists, tracks, and much more. In particular, one is used as a client and requests this information to use full services, while the other is a web service that lay between the client and the Spotify player. This process is obviously dynamic. Once a day, the user's informations are refreshed. The Spotify player, in orange, is the only actor that knows how to interact with Spotify in order to receive users' information, change his queue, get songs information, and much more. Each service that must exchange data with Spotify have to pass from this actor. Once the informations are collected and processed, they are stored on the Spotify catalog, in green, the one that collects only this type of information, and it is of course linked to the registered catalog. Other two services are involved. One, in blue on the left, is the Choose a Song web service, responsible to put together all the informations taken on a user, and thanks to a mix of algorithms, it will pull out a song according to its musical style, and, if the art rate is provided, more or less synchronize with it. The other is the monthly playlist service, in blue on the right. It is a client that once a month creates a new playlist according only to the user's preferences. It is a sort of gift that we decide to give to our clients. As expected, this client uses the Choose a Song web service explained before. If a new user is registered, after a few times, depending to internal implementation and connection speed, the informations will be collected, processed, and added to Spotify catalog, while the playlist will be created, added to Spotify catalog, and we could see it on the Spotify application. When a user starts training, everything he has to do is to switch on the fake sensor with the Start Sensor button. We can see that the message is correctly exchanged. The Telegram bot will send a notification to the other service that will trigger a reaction to the Docker application installed on the server. In particular, here we can see the two new containers are running. One is the fake sensor that will send the data to the broker. From here, the MQTT to REST adapter will ping each value to the sensor catalog. The other service is the one responsible to take users' musical preferences and their rate, taking the chosen song and add it to the queue of Spotify. It is implemented both in the Python GUI explained before, both in the form of image that can be used with Docker. It is not a web service but a client, and so one instance must run for each user. It is responsible to request information to some services. From sensor catalog, for example, it takes users' current data and perform a min. This value is sent to Choose Song web service that, together with the user's musical preferences taken directly from Spotify player, will pull out a correct song. This song will be sent both to Spotify player in order to be added to user's queue and Spotify catalog to be visualized together with other data from Freeboard. We can see here the chosen song in the queue of Spotify. We can also receive, in a user-friendly way, our last available error rate taken from sensor catalog. When the user finishes training, he can stop his sensor with the appropriate command. The two containers will be immediately removed, while the session of the user will be deleted after a few seconds from sensor catalog. Obviously, the bot was made in order to manage a lot of users at the same time. This is why we decided to use Docker to simulate the fake sensor. At the end of the video, we will show the entire system working with our team. Now, let's have a look both to Freeboard and ThinkSpeak.
Information coming from the single user is stored on ThinkSpeak. The ThinkSpeak adapter first registers itself to the service catalog together with all the other services. We now try to add a new client. As we can see, when we click on Start, values coming from the HR sensor are published with their respective timestamp. Every time a new user is registered to the system, a new channel is created. When the user starts streaming, the adapter acts as a subscriber, receiving data from the broker using an MQTT protocol and concurrently sends in a streaming mode the values of heart rate to the ThinkSpeak channel using a put request. If the user has already been registered, his feeds are updated. The platform supports multiple users streaming heart rate values at the same time. In order to guarantee a clear visualization of the data, if the user doesn't access the application for more than a week, his feeds are cleared. If a user doesn't use the application for more than 30 days, the channel is deleted. Freeboard has been used as the front-end point for the user. By clicking the button Open Freeboard on the graphical interface, the user is redirected to the main page of the platform. As we can see, when this happens, the Freeboard web service asks the register catalog for all the information needed to create the user-specific dashboard. The JSON file is posted under the URI corresponding to the user, and it can be retrieved with a GET request made by the web service when it attempts to open the Freeboard interface. The user's dashboard can be loaded by clicking on Load Dashboard and selecting My Dashboard.json, creating in the same folder of the graphical interface. We can observe the trend of the heart rate and the instantaneous values imported from ThinkSpeak. The data sources from which this platform takes information are the register catalog, providing user info, the Spotify database, and the ThinkSpeak API, by sending GET requests to each of them every X seconds, depending on the type of data requested. As we can see, both the registered and the Spotify catalog have currently received the query and can synchronously respond to it, providing the information requested. We have a widget that informs the user about his activity levels depending on some specific thresholds based on the age of the user. The current playing song and the monthly playlists are displayed using an iframe that allows the user to directly play songs on the platform. The user's favorite genres and the mean values of the features representing the most listened songs are plotted in order to be compared with the ones of the current playing song, which is chosen accordingly to the mean heart rate and using a criterion of similarity with the personal taste of the user.
Here we can see the entire system working with 3 people connected. We can notice that Telegram bot manages two connections at the same time, as we can see also from Docker, while there is no problem also with the person connected via Python GUI. The different waiting time between Telegram's users and GUI users depends on internal implementation. In the end, the current playback will be resumed, and the song added to the queue. So the system is perfectly scalable also with many users.